I first open the Run dialog to access the Group Policy Management System. Select the Action tab and create a new GPO by entering the specified name. Following the steps in the lab documentation, I navigate to the Deny Access to this computer from the network policy and add the user associated with my student ID to the denied list. To use the delegation of control wizard, I open Active Directory Management through the Run dialog. Navigate to Finance OU created in the previous lab. Right-click on the OU. Select Delegate Control and follow the prompts to activate it. I randomly assign roles and permissions to complete the process successfully. For the JUMP server setup, I first install the remote desktop service by selecting Add Roles and Features in Server Manager and following the prompts to choose the remote desktop service and its features. After reviewing the available features, I proceed with the installation and wait for it to complete. To verify the installation, I open the Run dialog, type System Properties Remote, and confirm that I can modify the remote system properties. I then add the user associated with my student ID to the list of allowed users. Next, I run the command provided in the lab documentation in PowerShell to create a new inbound rule for the firewall. Once the command executes successfully, I verify the new inbound rule in Windows Firewall by checking the Inbound Rules section, where the rule created via PowerShell is visible. For the auditing task, I first use the run command and type secpol.msc, which opens the local security policy manager. I then navigate, as mentioned in the lab documentation, to find audit logon events and audit object access and enable them. To perform advanced policy management, I open the group policy management configuration window and navigate to the advanced audit policy by first going to the newly created GPO. I then select the Action tab and choose the Edit function, which opens the Group Policy Management Editor. From there, I navigate through Computer Configuration, then Policies, followed by Windows Settings, and finally Security Settings, as shown in the lab. Following the instructions in the lab, I configure policies for monitoring specific actions by choosing Object Access and modifying policies related to files to demonstrate the functionality. For the Protected Users Group implementation, I begin by opening Active Directory users and computers to create a new group named Protected Users within the users container. However, after attempting to create the group, I discover that it already exists. I then proceed to add the user associated with my student ID to the existing Protected Users group. Following this, I confirm the group properties to ensure that settings such as Kerberos pre-authentication are enabled as required. To enable Virtualization-Based Security (VBS), I first ensure that the system meets the necessary hardware requirements. I do this by opening System Information MS-Info32 through the Run dialog and verifying that virtualization support is enabled and compatible with VBS as it shows not enabled. It can be understood that the system meets the requirements. Next, I configure VBS using the Group Policy Editor. I open GPDDMSC and navigate through Computer Configuration Administrative Templates, System Device Guard. Within this section, I locate and enable the policy titled Turn On Virtualization-Based Security. While configuring this policy, I ensure that the required options for virtualization-based security and credential guard are selected as per the lab documentation. After applying and saving the settings, I restart the system to activate the changes. Finally, I verify that VBS and Credential Guard are running. I reopen System Information MS-Info32 and check the status under the Device Guard section here. I confirm that Credential Guard is active and functioning correctly, ensuring the system meets the security standards required by the lab instructions.